Yeah,
Spin around, let's see. That's pretty cool. All right. All right, what about this on the back side? How's that connected there and there? Is that a sharp point or is there material there?
This is material.
You're looking at the future.
So 0.61 kilograms. So the original was 1.9 kilograms. Okay, so you can see you've saved quite a bit of weight on that. Now the question is, what's the strength going to be?
Future engineers. These are high school students from across North Carolina.
Okay, so still there's a high stress there. So this is an area you want to work on and start maybe beef this up. See, nothing's happening over here.
And the future of engineering. This camp at North Carolina State University teaches high schoolers about additive manufacturing. It's better known as 3D printing.
It's a totally different way of manufacturing. What this allows us to do is to do designs, to make designs, and realize designs that couldn't be manufactured any other way.
You might know 3D printing or additive manufacturing from these. Animal figures or other decorations are made with the process and use a variety of materials, and they all exhibit incredible detail. And it's because 3D printing allows for creating objects with intricate geometric patterns and complex features that the process is revolutionizing manufacturing. Objects that were physically or financially impossible to make not long ago can now be created.
But there's certain sectors of manufacturing, there's certain areas, medical device manufacturing, custom medical implants, where we want low batch sizes of highly specialized components, highly complex components that are high value added. And this is where additive manufacturing really shines.
Take this brace for an airplane engine. The piece on the left was made in a traditional forging process. A die was slammed into hot metal. The piece on the right was made using additive manufacturing.
And the shape of this, in part, is constrained by the process from which it was made. With additive manufacturing, because we don't have a tool and we don't have a die, we're free to put geometries really wherever we want to. So that allows us to make these highly complex designs. And it allows us to remove material from places where it would be difficult to with a traditional process.
Both pieces are equal in strength, but the solid iron brace weighs almost 4.5 pounds. The brace that was redesigned using additive manufacturing weighs 3/4 pounds. Engineers designed the part on the computer, used software to test it, added materials to reinforce areas with the greatest stress, and removed excess material where it wasn't needed. The design was optimized before it was retested and then built.
3D printing has been around since the 1980s. Back then it was conceived as a way to simply test the designs of products, kind of a way of rapid prototyping something. It was quickly discovered that you could actually make products using 3D printing, and you can use designs and materials that were never possible before.
There are many types of 3D printing, and each employs a different technology that processes materials in various ways. For example, stereolithography fires a laser into a vat of polymer resin, tracing one layer of the object to be printed. The resin hardens at the point where the laser hits the surface, and once the object is traced, the platform within the vat drops by a fraction, and the next layer is traced. The process continues until the entire object is created. Laser melting fires a beam across a bed of material. The laser fuses the material. Once the layer is traced, the platform drops, and work on the next layer begins. There are new technologies and new applications continually being introduced in this rapidly changing field. But the common factor is that each item is manufactured one layer at a time, which allows for precision manufacturing.
And we develop new materials, new alloys, and new systems, and the process parameters to manufacture with those materials. So for instance, we're working on high temperature nickel superalloys for aerospace applications and actually additively manufacturing with those. Now the question is, we have years and years of experience working with these alloy systems with casting and forging. How is this additive manufacturing or 3D printing different than these traditional processes? Are the material properties the same? Is the crystallographic structure the same? And sometimes we know the answer to this and sometimes we don't.
What is known is that the technology is being utilized in designing and manufacturing a broader range of products. This is DesignBox. It's in Raleigh's Warehouse District, not far from the High-Tech Center on NC State's campus. Life is a startup company making custom footwear. Same process, each piece made one layer at a time, but just like that brace for the airplane, it is customized to fit a need.
We have an upper that we can sew. You can choose your print. So we have dozens and dozens of prints that you could choose from. And then from that, really, we're just doing some digital fabrication. So we're pretty much making everything here. So in terms of your heel strike, we can actually start to adjust how much cushioning you need in your heel. Some people need more, some people need less. In terms of the actual footbed, then we can also even customize that to match the foot of what you got. So each of these things are options, but we have already kind of a good range of sizing that we'll be able to do in terms of widths and lengths. So people can really just find the best fit. So it's a new digital cobbler model of trying to bring footwear making back to the downtowns all over the world.